How many problems ang pina-assignment ko, class?
Dalawa po ata, ma'am.
Dalawa. Okay, so for the first one, I just open my file. That is isentropic and isothermal, correct? One problem each. So for the first number, can you please discuss your solution or your answer, Miss Claudine?
Ma'am, yung sa isentropic po.
Isothermal.
Ma'am, yung isentropic lang po kasi yung nasagutan ko.
Who has an answer on the isothermal problem? Isothermal process problem. Yes, Miss Shane, can you please discuss your answer?
Ma'am, yun po ba yung 2.5 kilogram of air?
Yes, correct. Please read the problem first.
Problem number 39. 2.5 kilogram of air gain 0.95 kilojoules per Kelvin of entropy during an isothermal process. If initial pressure is 830 kPa and final volume equals 1.20 cubic meter, determine initial volume and initial temperature and work non-flow.
Okay.
Sa pagkuha po ng initial volume, ang ginamit ko po ay delta S equals MRLN B2 over B1 kasi po given po yung entropy.
Okay.
Tapos po 0.95 kilojoules over Kelvin equals 2.5 kilograms times 0.287 kilojoules per kilogram Kelvin times ln 1.20 cubic meter over B1. Ang B1 po ay 0.3192693 cubic meter.
What's your T1? Ay, sorry, V1.
Opo.
What's the answer again? Sorry. For initial volume.
0.319269345 po.
Okay. So, thus your final volume is 1.2. We are looking for, sorry, this is V1. So using shift solve, you obtained 319 0.319. What's the continuation?
2693
269
245.
245 cubic meters. Okay.
Sa
How about the
pagkuha ng
sorry. How about the others, class? Is it clear? Is the solution clear? Okay, let's go to solve for T1.
Sa pagkuha naman po ng T1, ang ginamit ko po ay P1B1 equals MR T1 po. T1 equals 830 kilopascal times 0.319269345 cubic meter over 2.5 kilograms times 0.287 kilojoules per kilogram Kelvin po.
Okay.
Ang final answer po ay 369.3289747 Kelvin po.
Okay. 0.329 Kelvin. Then next
Sa
requirement.
sa pagkuha naman po ng work non-flow, ang ginamit ko pong formula ay P1B1 ln B2 over B1.
Okay.
Tapos ay input lang po lahat kasi given na po yung B1 kasi nakuha na po. Ang
Mm-mm.
magiging final answer po ay 350.8625259 kilojoules po.
The net is 350.863 kilojoules. Okay, thank you, Shane. Do you have a question on this problem, class? For those who were not able to answer this at home, is it now clear to you on what to do on this problem? Okay. So next number, Claudine, for the isentropic process problem.
Ma'am, sasabihin ko pa po yung problem.
Please read it first.
An ideal gas having a mass of 2 kg at 465 Kelvin and 415 kPa expands in a reversible adiabatic process to 133 kPa. The ideal gas constant is 0.242 kJ per kilogram Kelvin and K is equal to 1.40. Ang hinahanap po ay T2, delta, ay internal energy and work non-flow po.
Yes. So how will you get for T2?
Ang ginamit ko pong formula for T2 is T2 over T1 equal P2 over P1 raised to K minus 1 over K po.
Raise to K over,
K minus 1.
sorry, this
K
is,
minus 1 over K po.
yeah, this should be K minus 1 over K. Okay.
So ang magiging formula po is T2 is equal to T1 multiplied by P2 over P1 raised to K minus 1 over K.
Mm-mm.
So 465 Kelvin multiplied by 133 kilopascal over 415 kilopascal raised to 1.40 minus 1 over 1.40 po.
Correct. And
So
what for
ang
T2?
dito po ay 335.9340034 Kelvin or 335.934 Kelvin po.
Correct. Then next, the delta U.
Sa delta yun naman po, since ang formula po is MCV T2 minus T1, kinuha ko po muna yung CV which is R over K minus 1 po.
Okay.
So 0.242 over 1.4 minus 1. Ang nakuha ko po dun ay 0.065 kilojoule per kilogram Kelvin po.
Correct.
So this
065 or 605?
605 po. Then the substitute lang po yung mga value. 2 kilogram multiplied by 0.605 kilojoule per kilogram Kelvin multiplied by 335.9340034 Kelvin minus 465 Kelvin po.
Okay.
Ang nakuha pong sagot ay negative 156.1698559 kilojoule or negative 156.170 kilojoule po.
Negative 156.170.
7.
Correct. So this is your delta U. And what's
Doon
the
naman
requirement?
Do'n naman po sa work non-flow, meron po akong dalawang ginamit. Yung una po is the negative, ay work non-flow is equal to negative internal energy po. So, mu-multiply lang po siya sa negative. So, ang answer po ay positive 156.170 kilojoule po.
Correct. And what's the other one that you mentioned?
MR T2 minus T1 over 1 minus K po.
MR T2 minus T1 over 1 minus K. Okay?
So, 2 kilogram times 0.242 kilojoule per kilogram Kelvin multiplied by 335.9340034 Kelvin minus 465 Kelvin over 1 minus 1.40 po.
Okay.
The answer po is parehas lang nung internal and the positive internal energy which is 156.1698559 or 156.170 kilojoule.
Okay. Very good. Thank you, Claudine.
Thank you po, ma'am.
Everyone can follow on the solution. Is everything clear? Ashley, Bea, Giancarlo, do you have questions? Class, isothermal and isentropic. So if none, we will proceed on the last process, which is the polytropic process. Let me just clear this. Yeah. Wait lang. Okay, so let's proceed to the polytropic process. So this will be the last ideal gas process that we are going to discuss. So what is polytropic process, Warian? Warian?
A polytropic process is a reversible process during which PVN equals C, where N is a constant called polytropic exponent.
Okay. So class, polytropic process is a reversible process during which PV raised to N is equal to C. So this is an internally reversible process. So the previous four processes discussed, so we have isothermal, isochoric, isobaric, and isentropic, is also a polytropic process with various polytropic coefficient n. Di ba in the beginning of this topic, we discussed the different values of n depending on the process. So everything discussed, every processes discussed falls under polytropic process. It's just that the n value differs per each process. Clear? Okay. So now we will define a special case of polytropic process wherein n is any positive real number and is not equal to k. Remember, in isentropic or adiabatic process, our n value is equal to k. So in this case, in polytropic process, n will be any positive real number except 1 and infinity. Since 1, we already have that on a isentropic process. Sorry, isentropic process. And now we will be having our diagrams. So the PV diagram in a polytropic process will look like this. So you have your pressure on the y-axis, your volume on the x-axis, and let's say you have here your initial state point, and then you have here your final state point. So your work non-flow is the area under the region. So this region, so under the plane. And same for the TS diagram. You have the temperature on the y-axis and the entropy on the x-axis. And then you have here your initial state point going to undergoing a polytropic process to state point 2. So this is your TS diagram and this is your heat transfer. So the area here is the heat transfer. Okay, so let's proceed to the formulas under polytropic process. First one will have the combined gas law or the relationship between pressure, volume, and temperature. Remember, we have P1 V1 over T1 equals P2 V2 over T2. And in a polytropic process, we have PV raised to N. This is our constant term. And N here is any positive real number. So any positive real number. So therefore, we are going to derive the pressure volume relation. So let's proceed first on the pressure volume. So we will be focusing on the pressure and volume parameters. So we will disregard first the temperature. So for the first formula, we'll have P1 V1 raised to N. So that is our constant. So this will be equal to P2 V2 raised to N. And we can combine similar terms. We can combine both pressure and volume. So on the left side, we can have here the pressure. And then on the right side, we'll have V2 raised to N over V1 raised to N. So in here, we can combine V2 and V1 and enclose that in a parenthesis raised to N, right? So we can rewrite this as V2 over V1 raised to N. Okay, so the property of exponents. And from here, we can derive the value of n. So sometimes in a problem, we are given of the values of pressure and volume. However, we are not given of the value of n. And sometimes this is the unknown. So later we have a sample problem for that. So what we'll do is we take the ln of these both of both of the terms. So we can write this as ln P1 over P2 is equal to ln V2 over V1 raised to n. And one of the properties of natural logarithm is that we can have this as uh, we can have we can rewrite this term as n ln of V2 over V1. So in order to find n, we can have it as ln P1 over P2 over ln V2 over V1. Okay, so this is a formula to find the n or the polytropic coefficient. Is it clear? Okay, now next class, we are going to derive the volume temperature relation. So in volume temperature relation and from the combined gas law, we can derive um, the relation as P2 over P1 equals V1 over V2 times T2 over T1. So this came from the combined gas law class. So you have here, for example, P2 over P1. So you have that on the right side. And then you have V1 on the numerator divided by V2. So you'll transpose V2 on the denominator. And then for the T2, you'll cross multiply. So T2 will be on the numerator and then T1 will be on the denominator. So here's your equation. And as you can see from the initial equation that we have here on the left side, P1 over P2 is equal to V2 raised to n over V1 raised to n. So in this case, I can rewrite P2 over P1 as V1 raised to n over V2 raised to n. So this will be equal to V1 over V2 times T2 over T1. Is it clear, class? Or do you have any doubts here? So V1 raised to n over V2 raised to n came from the initial, the first formula that we had. So in here, as you can see, P1 over P2 is equal to V2 raised to n over V1 raised to n. So I just copy that and reciprocate since what I have here is P2 over P1 and what I had here is P1 over P2. Do you guys can follow, class? Okay, so let's continue. So from this class, we can have T2 over T1 be equal to, so we're getting this ratio. T2 over T1 will be equal to V1 raised to n over V2 raised to n over divided by this term V1 over V2. And then Since remember properties of exponent, this has an invisible one exponent, right? So every variable that we have that doesn't have exponent, it has an invisible one exponent. So in this case, we have an exponent on the denominator, which is 1. So this applies to all class. So from this uh ratio, or from this term, we can rewrite this already as, so this numerator, we can have it written like the n is outside. One property also of exponents. So we can have this as v1 over v2 raised to n over v1 over v2 raised to 1. And if you have a denominator which is raised to 1, and if you put this on the numerator side, you'll have the exponent as negative. So, this will be T2 over T1 magiging V1 over V2 raised to N minus 1. So, this minus 1 here came from the exponent on the denominator. Clear, class? 'Di ba, the term will be v1 over v2 raised to n times v1 over v2 raised to 1. And properties of exponents, we can have that written as v1 over v2. Sorry, that is negative 1. So v1 over v2 raised to n minus 1. So this is the formula for the relationship of temperature and volume. So in here, on the first one here, we have the pressure and volume relationship. Number 2, we have here the temperature and volume relationship. Lastly, we will derive the pressure and pressure and temperature relationship. So that's the last derivation that we'll have for the first formula. So for the pressure and temperature relationship, from the previously derived volume temperature relation, so di ba we have here T2 over T1 is equal to P2 over P1 divided by V1 over V2. So we can have it written as T2 over T1. So coming from the combined gas law, this will become T2 over T1. This here. T2 over T1 is equal to P2 over P1. So this will become raised to n minus 1. And then we'll have T1 over T2 raised to n minus 1. And we can rewrite this as T2 over T1 is equal to P2 over P1 raised to n minus 1. And then this term here, we can have the T2 in the numerator. So this will become T2 over T1, but the exponent will be reversed. So this will become 1 minus n. Since we will multiply this to negative 1, since we reciprocate this term. So simplifying what we have here, we can write this as T2 over T1 is equal to P2 over P1 raised to n minus 1 over n. And this is the pressure and temperature relationship. So we have here three formula under combined gas law, or the relationship of pressure, volume, and temperature. So one, pressure and volume. Number two, we have volume and temperature. And number three, we have temperature and pressure. And we have additional formula in finding the n value, or the polytropic coefficient. Okay. Next formula will have the work non-flow. Work non-flow class still the same. So this is the integral of P dV. So from process definition, we have PV raised to n is the constant value. And again, n is any positive real number. So we can rewrite the pressure as, we'll get the value of pressure. So we can substitute here. So pressure is equal to C over Vn, right? Or we can rewrite this as P is equal to C V raised to negative n, since we put V in the numerator side. So substituting to the integral formula, we'll substitute this value. This will be integral of C V raised to negative n dV. And since C is a constant value, this will bring C outside of the integral equation, and we will be left with V raised to negative n dV. So this is the term that we are going to integrate. Then we will integrate this value here, the term here. So this will be C times, diba, V negative n plus 1. So this will be V negative n plus 1 over this term. So negative n plus 1. And we will evaluate this from 1 to 2, or state point 1 to 2. So I'll just rewrite this. This will be V raised to 1 minus n over 1 minus n, evaluated from 1 to 2. And our constant is equal to Cv raised to negative n. So this will become, sorry, constant natin is Pv raised to n, sorry, here. Constant natin is Pv raised to n, so this will be written as Pv raised to n times this value. So V raised to 1 minus n over n minus 1. Sorry, 1 minus n. It is. This will become evaluated from state point 1 to 2. Then, we'll multiply this term to this term. So, we have v raised to n times v raised to 1 minus n. So, that will become p, magiging v na lang. So, v raised to n times v raised to 1 minus n will become v over 1 minus n. So, this will evaluate from 1 to 2. So, final equation natin for work non-flow, this will be equal to PV over 1 minus N evaluated from 1 to 2. So, this will become P2 V2 from this minus P1 V1 all over 1 minus N. Or, or work non-flow can be also from ideal gas law. Can rewrite this as MR T2 minus T1 over 1 minus N. So here's the formula for the work non-flow. Okay? So number 3, we'll have also the change in internal energy. So this is still equal to MCV T2 minus T1. And then for the heat transferred, so number 4, we have Q is equal to delta U plus work non-flow, right? From the general equation. So, we are going to rewrite this. So, we'll substitute the formula for the internal energy, which is mCv T2 minus T1 times the formula for the work non-flow, this one. We'll have mR T2 minus T1 over 1 minus N. And from the properties of ideal gas, we have a formula that Cv is equal to R over K minus 1 and R is equal to Cv times K minus 1. But we have Cv equals R over K minus 1. So this formula here will replace this R by Cv times K minus 1. So we'll rewrite. So here R will be equal to Cv times K minus 1. And we will substitute this R value here, or the term, or the formula. So this will now be written as mCv T2 minus T1 plus M times R natin is Cv times K minus 1 times T2 minus T1 all over 1 minus N. Okay? And then, we can factor out mCv T2 minus T1. So that is the common term. So we have here mCv delta T. We have here mCv delta T. So we can factor it out. So mCv T2 minus T1. Oops. Factor out. So that will be 1 plus what will be left here. K minus 1 na lang. So we already factored out mCv delta T. So what we're left with here is K minus 1 over 1 minus K. 1 minus N. And we can find the common denominator here. So we can have this as mcv T2 minus T1 times, so this will be 1 minus n, iko-common na natin siya. And 1 minus n times 1 minus n is 1 minus n plus k minus 1. So this will be now mcv T2 minus T1. So 1 minus 1 is 0. So we will be left with negative n plus k. So I will write this na as k minus n. Diba, negative n minus plus k na lang yung matitira. Or what will be left here is negative n plus k. So I just wrote it as negative n, k minus n. So this will be over 1 minus n. So next, the formula for Q is this. And I am going to introduce to you guys another formula. So for getting the specific heat under polytropic process. So remember this. We'll introduce Cn. So Cn is the specific heat under polytropic process. So Cn is equal to Cv raised to k minus 1 over 1 minus n. Remember this formula. And then from here, we can rewrite the formula for heat to be mCn delta T. So if you remember this formula, the Cn, you can have the Q or the heat transferred to be mCn delta T. But if you don't remember this formula, you can use this one. So you have here the Cn value, which is Cv times k minus 1 over 1 minus n. So that is where this formula came from. Clear, class? Are you clear with the derivation? Okay. So next, enthalpy. So enthalpy, class, is still the same. So I'll just go back on the previous slide. I'll erase this. So enthalpy number 4, delta H is still equal to mcp delta T. And then entropy, for the entropy, will have dq over T, right? Oops. dq over T. And from the formula that we had earlier, dq is equal to mcn delta T over T. So this will become, delta S natin will become mcn. So this is constant. We will be left with dt over t, and we know that that is ln of t. So ln of t from state point 2 minus ln of t at state point 1, we can write that as ln of t2 over t1. So this is the formula for entropy. So from the PVT relationship a while ago, class, diba, we have T2 over T1 being equal to V1 over V2 raised to n minus 1. So we can rewrite this equation or this formula to, we can replace this by this. So we can also have MCN ln of V1 over V2 raised to n minus 1. And another relationship that we had is T2 over T1 is equal to P2 over P1 raised to n minus 1 over n. So your entropy or delta S can be also written as MCN ln of P2 over P1 raised to n minus 1 over n. So you'll have three available formula for delta S. Okay? Clear class? So this came from dq over dt. Everything naman or every entropy change in entropy will be coming from the integral of dq over dt. And your q is mcn delta t. That's why we have here the value of a specific heat under polytropic process. Okay? Next naman, we'll have the work steady flow. So for the work steady flow, so I'll just clear this number 5. Number 6, we have the work steady flow. For the work steady flow class, we'll still follow the formula negative of integral of VdP. And from the definition again of the process PV raised to n equals to C, we can get the value of V. So the value of V will be equal to C raised to 1 over n. So we remove the formula, the exponent of V, which is n. So if we get C, this will be raised to 1 over n. And another one is P raised to negative 1 over n. So this will be the value of your V. And substituting this value of V to the integral formula, we'll have work steady flow. Work steady flow is equal to negative. Ilalabas ko na yung C raised to 1 over n. So this is constant. So I'll bring that outside of the integral equation. Integral of P raised to negative 1 over n dP. So this is your working equation. And then integral of this, or when we integrate this will become C raised to 1 over n times P, diba, negative 1 over n plus 1. So that will become 1 minus 1 over n over this exponent here. So this is negative pala. Negative 1 over n plus 1. So this is 1 over n minus 1. Then, final derivation, This will become, substituting for the value of the constant, we'll have PV raised to n times 1 over n multiplied by p raised to 1 minus 1 over n all over 1 minus n. So simplifying further, we'll have the work steady flow as n times P2 V2 minus P1 V1 all over 1 minus n. So remember, this is also the formula for the work non-flow, right? P2V2 minus P1V1 over 1 minus n is your formula for work non-flow. So we can also write this as n times mr T2 minus T1 over 1 minus n. Or simply, if you memorize the formula of work non-flow, your work steady flow is equivalent to n times work non-flow, or n times integral of pdv if you're gonna use the general equation. What are we missing here? We only have 6 formula. Entropy, enthalpy, heat transferred, internal energy, work non-flow. 1, 2, 3, 4, 5, 6, 7. Oh, we already have 7 formula. So this is number 7. Okay. So we'll have one sample problem for polytropic process. Oh, we have 2 here. I prepared 2 for you. First one, what sample problem number are we now? So sample problem number 42. Please read the problem, Giancarlo.
Sample problem number 42. During a polytropic process, 4.5 kilogram of an ideal gas whose R is equal to 0.2153 kilojoule per kilogram Kelvin and Cp is equal to 1.047 kilojoule per kilogram Kelvin changes state from 138 kilopascal and 5 degrees Celsius to 827 kilopascal and 171 degrees Celsius. Determine A and B change in internal energy and change in enthalpy, and C work non-flow, D heat po.
Okay. So first requirement, before we proceed on the solution class, let us first have the given, analyze the given or the problem by first listing down the given data. So during a polytropic process, so process natin is PV raised to n. This is the constant. 4.5 is our mass. So it is an ideal gas with a gas constant of 0.2153 kilojoule per kilogram Kelvin. Cp is 1.047 kilojoule per kilogram Kelvin. Changes state from, so this is the initial state. From P1 is 138 kilopascal and T1 is 5 degrees Celsius plus 273.15. This is 278.15 Kelvin. And then the final state, so after the polytropic process, the final state is P2 is equal to 827 kilopascals. And then the final temperature is 171 degrees Celsius. So plus 273.15 Kelvin. Sorry. Plus 273.15. What is the final temperature, class?
444.15 po.
444.15 Kelvin. So these are the given data. So for the first one, as you can see here, class, we have P1, T1, P2, and T2. So how can we get for the first requirement or for the value of n? Anyone?
CP over CV po.
So this is, class, this is not K, no? As, okay, so we can have pala yung CV. Yung CP over CV, class, is the K value or specific heat ratio. So in a polytropic process, the specific heat ratio is not equal to the N value or the polytropic coefficient. So we cannot use CP over CV. What we'll get there is the value of K, not the value of N. From the relationship of pressure and temperature, do you think we can get the value of N? What again is the relationship or the formula for the relationship of pressure and temperature, class? The one discussed earlier. What is the formula in finding or for the relationship of pressure and temperature? Yung number one, P2 over P1 raised to n minus 1 over n. And from the given data, you can see that we already have P1, T1, P2, and T2. So we can substitute those values here and we are left with one unknown. So we have one equation, one unknown. We can already solve for the value of n. Okay? So get your calculators, class, and substitute the values of T2, T1, P2, and P1 here to get for the value of n. So you can use shift solve. So T2 is yan. Substitute these values, class, this given data on the top of your screen. Substitute that here on the formula here. John Vincent, what's your answer? Mr. Zorilla? Mr. Zorilla, you'll just substitute the values. What's your answer? Mr. Zarilla.
Ano po? Ito ang nahina lang po ulit.
Okay, what's the value of n?
1.35386. 1.35. 1.35 po.
What's the whole value? I mean the without rounding off.
1.35386 34 37 po.
37. So this is the value of n plus. So in 3 decimal places, this is 1.354. So you already have your n value. So your n value class ha, use 3 decimal places during your solution or during the process of solving. Do not round it to 2 decimal places only. You'll have a different answer or a large discrepancy on the true answer. So minimum 3 decimal places. This will be multiplied on the succeeding parameters to solve for the requirements. Okay, next. So we already get the value of n. Next naman, we are asked to find the value of delta U or the change in internal energy. So to solve for the change in internal energy, what is the formula again? Marjolaine?
Ma'am, ulit nga po ulit. Sorry po.
What's the formula to get delta U?
MCV times delta T po.
MCV delta T. And using or substituting the given data, your M is 4.5 kilograms and your CV is not given yet. How will you get for the value of CV? Marjolaine?
Sa pagkuha po ng CV ay, ang ginawa ko po ay CP minus CV equals R. So, manipulate po natin ng CV equals CP minus R. So substitute po ng mga value na given. Ang CP po ay 1.07047 kilojoules over kilograms K minus 0.2153 kilojoules over kilogram K. Ang sagot po ay 0.8317 kilojoules over kilogram K.
0 point.
8317 po.
Okay. And then substituting that here, that CV here, what is your internal energy? Yes, Marjeline?
621.2799 kilojoules po.
621.2799
2799
unit is
kilojoules po.
kilojoules. Or in 3 decimal places, this is 621.28 kilojoules. So, okay na tayo on the delta U. How about the change in enthalpy? John Jeremy Batas, how would you get for the change in enthalpy.
MCP delta T po.
Correct? So this is mCp delta T. And what is your answer? Substituting the given data, you have already the CP. CP is 1.047.
782.109 po.
Is that the rounded value already?
Yes po.
Okay. This is 782.
0.109 po.
0.109 kilojoules. So this is your answer. And then for the last requirement, we are no, not the last. We are going to find then the work non-flow. Second to the last requirement. Work non-flow, what is our formula? So from the long derivation, what is the formula for work non-flow? We can use Ashley. What is the formula for work non-flow? Ashley, Jerome, Mr. Esplana, hello? Mr. Esplana, are you there?
Hello po, ma'am.
Yes. What's the formula for work non-flow?
Ano po, ma'am? Hindi po kayo audible sa akin. Ano po ulit, ma'am?
What is the formula for the work non-flow?
Work non-flow po ay PDV or PV po.
What is the final formula? That is the general equation from the derivation that we did earlier. So we have two formulas for the work non-flow using PV and using MRT. What is the derived formula? Mr. Panopio, yes. What's the formula here to be used?
Pwede mong gamitin is yung MR delta T over 1 minus N.
Correct. So we are going to use MR delta T over 1 minus N. Since we are not given of the value of volume class, it is better to use this formula than to get for the value of volume, since medyo magkakaroon na kayo, lalayo na kayo sa sagot ng for the work non-flow, like for the answer for the work non-flow. So using MR delta T over 1 minus N, we are just going to substitute the values that we have. So earlier we already obtained the value of N. M is given, R is given, T2 and T1 are also given. So the work non-flow here is, Mr. Panopio, can you please calculate and tell me the
Uh,
work non-flow?
454.32 po.
400.
54 po. 0.32.
Is that rounded?
Opo. Ay,
Tell me the
319 po. Pag 3 digits.
319 9999
49 po. 3194915.
15. Unit is? What's the unit of work? Okay, kilojoules. Or in three decimal places, this will be 454.319 kilojoules. T2 minus T1, R is... Hmm,
Opo, ma'am. Negative yung lumabas sa calculate.
because your N is bigger than 1. So yeah, this is negative. Correct. How about the others? Do you also get the same answer?
Opo, ma'am.
Allen May? Yes, Shane?
Ano pong gagamitin na N, yung naka-round off na po o yung buo po? Pag nagsusolve po.
Yung buo. Pero in
Sige
your
po.
paper, you can just write, di ba, magsusulat kayo ng equation. It's okay for me to write the rounded value. But in the calculator, you have to use the whole value of n, not the rounded one. Okay, but in your answer sheet or in your solution, you can just write the rounded value for the sake of ano na lang din, time in writing. Okay? Yes, Mr. Falogme.
Ma'am, ang ginamit ko po ay buong N, ang lumabas po ay 0.49 po.
So the value here is 454.
454.4948225.
225. So then, the final, this is the correct one then. So do not use the rounded value in the calculation. So work non-flow natin will be negative 454.495 rounded to 3 decimal places. So always use the original value of n, not the rounded one. So, ayan. Okay, class? And for the last requirement, we are asked to find the value of heat. So letter D, heat, what is the formula? It's the formula for heat. Charles Benedict.
Ma'am, the formula po is Q is equals to MC and delta T po.
Q is equal to mCn delta T. However, we do not have the value of Cn yet. And what is the formula for Cn, class?
The formula po is Cn is equal to CV times K minus N over 1 minus N po.
Over 1 minus n. So, do we have the value of K? Class? Do you have the value of K?
Wala po.
Wala. Then, how are we going to get the value of K?
CP over CV po.
Cp over Cv. And what is the value of K from the given? What's K? 1.047 over 0.8317. What's the answer?
1.2588678 po.
886738. Okay, so let's substitute K, N, and CV here. What is CN? CV is 0.8317 times K, which is 1.25886,738 minus N, which is 1.354 over 1 minus N, or 1 over 1 minus 1.354. What is the value of Cn? Adham, what's your Cn? Adam, what's the value of Cn? You just need to substitute the formula of CV, K, and N. Adam, are you there? Has chance?
Wait, ma'am. Wait.
Okay.
Is it 0.22350790976?
0.22
350
350
790976.
kilojoule per kilogram Kelvin. Aldrin, did you get the same answer?
Ma'am, no po. Ang
What's your
nakuha ko
answer?
po nakuha ko po ay 0.2232731962.
Adham, did you use the rounded value? Or did you use the whole value?
I used N. Did the rounded one in N.
Ah, okay. So next time, please use the whole value, not the rounded one. Okay?
Okay, ma'am.
Okay. So Aldrin, what's the value of Cn?
0.2232731961.
Kilojoule per kilogram Kelvin. Okay, next. What's the next step from here? So you already have your Cn. You just need to substitute it on the formula. So Q is equal to mCn delta T. You already have the mass. You calculated already the Cn. and delta t is given. So what's the value of q? Yes, Mr. Hoson?
Ano po, ma'am? 146.6904898 kilojoules po.
146.6904898
Opo.
kilojoules. Or final answer natin here is 146.690 kilojoules. Okay, is it clear, class? Do you have questions? Yes, Joshua, May, Robert?
Ma'am, iba pong nakuha naming final answer.
Sa akin rin po.
Sa
Uh,
akin din.
what did you get?
166.7850775.
Yeah, actually, that is near 8. Mr. Hosan, kindly double check your calculator inputs.
Ma'am,
Maybe,
mali pala po yung T1 na nailagay ko. Akala ko po 298.15.
okay, sige. Um, Joshua, what's the answer? The final answer?
166.7850775.
775. Unit is kilojoules. So, final answer natin is 166.785 kilojoules. Thank you. So, that is sample problem number 42. So, do you have questions, class? So, yeah, Robert,
Na-late po ako kanina, ma'am, ng pasok.
Panopio. Okay, later I'll mark it. Okay, if you don't have questions, class, have this as your assignment. Sample problem number 43. So you can just take a screenshot. So this is PV raised to 1.5. This is PV raised to 1.5. Yan. Okay? And another assignment ko sa inyo, below your solution, so after the final answer, please write on your notebook the difference between work steady flow and work non-flow. Again, below your solution on sample problem number 43, please write the difference between work steady flow and work non-flow. Okay? Is it clear? Do you have questions, class? Okay. Tomorrow we'll discuss other problems and the answer on your assignment. Okay, that's all, class, for today. Have a nice day ahead.
Thank you po.
Thank you po.
Thank you po, ma'am.
Thank you po.
Thank you po.
Thank you.